Today we're going to do lab 3.1, first lab of unit 3. Now, unit 3 is all about abstraction, and abstraction is the main thing we're going to highlight in today's lab. In fact, today's lab is going to focus on the two kind of tenets of abstraction, which are detail hiding and generalization. We're going to do a little bit of each today. Now we're going to do this by doing basically a revisiting of a previous lab, but redoing it by using these new things we learned, like abstraction, detail hiding, and generalization. So by the end of this lab, what we're going to be able to do is you'll have something where you'll be able to either put in manually or ask how many sides your shape will have, and no matter what you type in, it'll be able to draw that shape. So if you put in 3, it'll draw a triangle. If you put in 4, it'll draw a square. If you put in 5, it'll draw a pentagon. And if you do this properly, it can go all the way up to 100. No matter how many shapes or how many sides you select, it's always going to be able to draw the shape. This is going to be the idea of generalization, where we're going to take something common and basically make it work no matter what value you put in. And we're going to do this by using detail hiding, by using the new feature in Snap that we're going to learn about in Unit 3, which is custom blocks. In the first part of this lab, what we're going to talk about is the concept of detail hiding. It's the first concept of abstraction that we described. The concept of detail hiding is you strip away all of the unnecessary details so that all you're left with is exactly what you need. So for example, if all you need to do is make a square, then we're going to strip out everything except the idea of making a square. All right? So we take away all of those details. So let's discuss this in terms of an example. So to start with, we're going to start with the same example that we've used a billion times in this class. We've done a drawing of the square as follows many times. Basically put the pen down and you repeat 4 times the act of going 100 steps forward, turning 90 degrees. You do that 4 times, you make a square, right? And then we put the pen up to be good citizens. So we've done this before, just makes a square. Now what we're going to do is we're going to treat these as details, and we are going to remove these details from the equation by basically using one of the new aspects that we're going to learn about in Unit 3 of Snap called a custom block. That's going to allow us to draw a square without having to worry about how we do it. So to do that, whenever you want to make a custom block, you can click on any of the categories to choose where you make your custom block, and it'll make it for that category. We're going to do this under motion. All right? Now, if you scroll all the way to the bottom, what you'll see is a button that says Make a Block. Now, what we're doing here is we're making a block just like any of these other blocks. So far, we've only worked with blocks that Snap provides for us. What Make a Block lets you do is it lets you make one of your own. Lets you make one of these things. All right? So let's click Make a Block. It's going to give you all of these handy options. The first option is what category it should go under. We're going to put it under motion. The next one is what kind of block. For this class, and for probably most labs, it's just going to be a command. So usually the answer is command. And the next thing we're going to do is we're going to give it a name. Now, the name can be anything, but it should be something descriptive. In this case, we're going to make a square. That's what we want to do. So we're going to call this Make a Square. All right? And then we hit OK. And now what you'll see is you'll see this block editor come up that you can drag blocks into. And also, you'll see it show up here at the bottom. We'll see a little more about that in a sec. So the first thing we're going to do is we are going to drag our code for making a square into the block editor. And we're going to snap it into here. This is the behavior for how to make a square. This is, if you will, the details behind how a square is made. And then we're going to hit OK. Now you'll see that we don't have any of the code here anymore, but we have a block called Make a Square in the motion category. So I'm going to grab this block and I'm going to move it into our scene. And now what you'll see is if I click on this block, it's going to make a square. Now here we've used abstraction, we've used detail hiding, because how we make that square does not matter to us. We don't care about that detail. All we care about is that when we want to make a square, we want to use this, and then we can draw that square. In fact, you can use that to make a square multiple times. So for example, to do something similar to Lab 2.2, we're going to make a square, we're going to move 100 steps, and we're going to do that 3 times. And now when I click on the green flag, let's clear this out, it'll make the square 3 times. And notice that every time I needed to make a square, I no longer need to specify each of the steps, each of the details. I can simply use the Make a Square block that we've created. And there we have it. This is detail hiding. We have hidden the details behind making a square, and we have performed abstraction. This is the first part of the lab. The next thing we're going to do is we're going to talk about generalization. So we talked about detail hiding and abstraction, but the other part of abstraction that we learned about in this lesson is generalization. Now, the ability to generalize is very important. It's going to let us take something that is similar about a solution and make it work kind of in the general case. So let's look at a specific example to see what that means. So here what we have is you can see three different ways of making a square. So we have this one, we have this one, and we have this one. These are the same square but different sizes. Now if you look carefully at the blocks here, you'll see that they're basically all the same with one little exception. The only thing that varies here is how much we move in each of these scripts, right? So here, if we want to generalize this, we will say that the only thing that differs from the drawing script for a square is how many steps to move. Now what we're going to see is if we can use this in order to make a general solution for drawing a square of any size. All right, so we already have a block that we just made called make a square. Now the problem with make a square is that no matter how many times you click on it, it's always going to make the same size square, and the square is size 100. That's how we defined it, right? Now we want to be able to specify how many steps we want to move, how big the square is going to be. If you recall, all of the blocks almost that we've worked with in this class have had this ability for us to specify something. Here we have move 10 steps. Imagine if it was just called move step, and every time we wanted to move steps, we had to repeat this block 10 times. That wouldn't be very effective, right? So the ability to specify how much to do something or some other detail about how much to do something, this is what we will call a parameter, right? This is going to be a way of making a generalized solution, specifying just how big the square is going to be. Now, making a parameter like this is actually fairly straightforward. We're going to right-click on our block, and we're going to do Edit so that we can modify our custom block. Now, when you have the block, you will see at the top, remember that we were able to name the block something. We call it made a square. And we can actually add more to this by clicking on this plus. So here, I'm going to call this block make a square, and I'm going to put title text. I'm going to put of size n. So I'm going to be able to specify how big the size of this square will be. Now, if you notice, what this will do if I hit OK is it will change the name. So it's now called make a square of size n. Now what I want to do is I want to make it so instead of n, it's one of these little boxes where I can put information. So let's go edit again, and let's just click on that n. And instead of making it a title text, I'm going to call it input name. All right. Now notice that now it turned orange. And if I hit OK, what I'm actually going to see is that now, instead of being make a square of size n, it's going to have a little box where I can type the size, like 100. Now, to make this work, I actually have to use this. So let's go to Edit. Now this n, you might find familiar, especially the fact that it's orange. This is a variable. This has now become a parameter that we can use as a variable. So the way I'm going to use this is just like any other variable. Instead of moving 100 steps, I'm going to move by the number that we specified in the text box. That's going to be this variable n. I'm going to drag that right into here under move n steps. So now instead of always moving 100 steps, I'll be able to specify in a generalized fashion how many steps to move. So let's hit OK. And let's try this out. Now if I want to make a square of size 20, like in this script below me, I just put 20 and I click on it, and it'll make this tiny little square. If I want to make a square of size 50, I can put 50 here, and it'll make a bigger square. And just like this one here, if I want to make it size 100, I put 100 and I click on it, and it'll make the bigger square. And in fact, I can use as many of these as I want. I can make it draw a square of size 20, and followed by a square of size 50, followed by a square of size 100. And it'll do each of these separately, right? So here we have applied the last concept of abstraction we learned about today, which is generalization, taking a solution and finding a generalized way to represent that. So this is actually what we did here with the size is not one of the parts of the lab, but it's going to build up for the next part of the lab where we're going to do this, but with the number of sides to draw a variety of different shapes. All right, we're going to use the same concept of generalization. So we'll get right to that. All right, so now we're going to go to the next step. In the next step, we're going to do is we're going to use generalization and detail hiding in order to create a block that will let us draw a shape of any size, or sorry, of any number of sides, right? So instead of just being a square that is different sizes, we're going to be able to specify the number of sides and it'll draw that. So without the abstraction, so without the custom block, it would look like this. We could have this repeat 3 times to draw a triangle. It'll have to turn 120 degrees. Here, it has to repeat 4 times, but it's going to turn 90 degrees. And here, for the pentagon, it's going to repeat 5 times, and each one of those is going to turn 72 degrees. We've done this lab before to draw the shapes. Let's take for granted now that the number of degrees to turn is going to be something we just kind of know beforehand. 120, 90, 72. Turns out there's a pattern here that we're going to discuss shortly. All right? So this is the non-generalized, the non-abstracted way of solving this problem. So let's create a new block called make a shape, not a square anymore, of size, let's call it make a shape with number of sides s. All right? Put that also in motion. So here we're going to be able to make a shape with 3 sides, 4 sides, 5 sides, etc. Now, we start with this. This is just text. This is what the block looks like right now. And we want to put a little text box here so we can put in the number of sides ourselves. So to do that, once again, remember, you just click on that S, and we make it an input name instead of a title text. So we click on the input name, and then we hit OK. And just like before, now this is a variable. This is a variable S. If you hit OK, you'll see I can tell it how many sides I want. So make a shape with number of sides, and I can put in 3, or I can put in 4, etc. Now this is the number of sides. It's not the length of the sides, right? So it says 3 for triangle, 4 for square, 5 for pentagon, etc. So for now, let's start by doing this the simple way, right? The simple but maybe kind of ugly way. So to do that, let's right-click and let's do Edit. And let's do this kind of the old-fashioned way. The old-fashioned way is we're going to use a bunch of if-elses, right? In fact, just to make it nice and simple, we're going to need our ifs. So what we're going to say is if s is 3, so if s, remember this is just like a variable, we can drag it in. So if the person put 3 into the text box, we are going to draw a triangle. So that's the triangle that we had set up over here. If, on the other hand, s is 4, so if s equals 4, we're going to draw the square. And finally, one more of these. If s equals 5, I'm going to right-click and duplicate that right here. I'm going to draw the pentagon that we had set aside earlier. Right? So let's see how this works. Basically, we're going to say make a shape with number of sides s. S is what we're going to be able to put into the little text box over here. And then what we're going to do is we're going to look at s, and we're going to check what it is. If s is 3, we want a triangle. If s is 4, we want a square. If s is 5, we want a pentagon. And then we'll just draw each of those shapes. Okay? So let's see how that works out. If I put 3, it'll draw the triangle. If I put 4, it'll draw the square. If I put 5, it'll draw the pentagon. Now what happens if I put 6? It doesn't know what to draw, because here we had to specify each and every one of the things for it to draw. But for this lab, it turns out that there is a nice little trick that we can use to further generalize this. And we'll get to that right away. So now we're on the last step. I am going to basically get rid of the work we did for make a shape with number of sides, because I'm going to do it a little bit differently, in a way that's a little more elegant. So in the previous issue we ran into is we could kind of generalize the drawing of shapes given the number of sides, but we couldn't do so perfectly. We only did so with 3 different shapes, right? Triangle, square, pentagon. So let's see if we can improve on this. So let's start with an empty custom block. This is the block that we just created, make a shape with number of sides, right? So we want to be able to specify 3 for triangle, 4 for square, 5 for pentagon, but we want it to work for any number of sides, right? So for example, it should work for 6, it should work for 7, etc. So how do we do this? It seems impossible, right? You'd need to have an infinite number of if statements. How could you possibly represent every shape? Well, it turns out there's a little bit of math that we can do for this to work. Now, you don't need to know this formula beforehand. We gave this to you in the lab. We just want you to figure out how to apply it. Let's look at these 3 shapes, right? These are the 3 shapes that we started with, but they have a pattern. So the obvious part of the pattern is that the repeat has a number, which is the number of sides, right? So for triangle, the repeat is 3. For square, it's 4. For pentagon, it's 5. So that part's obvious. Now the part that's not obvious is, what about this? Here, we have different degrees that we have to turn in order to draw this shape. Now, if you think about it a little bit and you do some math, you will find that there's actually a pattern here. And the pattern is this number is actually 360 divided by the number of sides. So for example, for a triangle, we get to turn 120 degrees, and that number we can find out by doing 360 divided by 3, which is 120. For square, it's the same thing. If we do 360 divided by 4, we get 90. And same thing for pentagon. If we do 360 divided by 5, we get 72. And what you can actually find mathematically is that this works for any number of sides. So whether it's just a triangle or a shape with 100 sides, this will always work. Let's give that a shot. Let's see how that would look. So the way we'd represent this, the way we can generalize this, we still want to just specify the number of sides. But now we're going to do a little bit of math, and we're going to do a little bit of smart usage here. Now remember, this is the number of sides. It is not the length of the shape. It is not the size of each length. It is the number of sides. So it's going to be 3 or 4 or 5, etc. Right? So what we're going to do is we're going to drag this in. Now obviously, if the number of sides is 3, we know that we're going to repeat it that many times. So we already know that whatever we put in here, 3, 4, 5, is going to be the exact same number that we put for the repeat. So for a triangle, we put 3. For a square, we put 4, etc. So automatically, we can just repeat by the number of sides here, right? So remember, if I put in 3 here, this will be 3. We'll repeat 3 times. If I put 4, this will be 4 repeats. If I put 5, this will be 5 repeats, right? That's what S becomes. It's a variable that has that number. Now the one that's less obvious was this one here, turn degrees, right? Now what we said is you can do some math here, and if you do 360 divided by the number of sides, you'll get this number. So for that, we want to do some division, so we'll use this operator, right? And the math we wanted to do is 360 divided by the number of sides. And we can put that into here. So now what we have is we're going to make a shape with number of sides S, and to figure out how many times we repeat, that's just S, the number we specified. We're going to repeat that many times. Each time we're going to move 100 steps. And finally, the amount we have to turn for each one of those is 360 divided by S based on that formula that we just let you know about. All right? So let's hit OK, and let's see how this works out. Let's clear this out. And now we can make a shape with number of sides S. So if we put 3, we're going to make a triangle. If we put 4, we put a square. If we put 5, it's a pentagon. But let's see if 6 works. 6 works. Here we have a hexagon. We have an octagon for 8. And check it out. Even if I do 100, it'll be a very big shape, but it'll still draw it. 100 sides, right? This is how we generalize a formula like drawing a shape. We find a pattern that works, and we apply it. We then have a nice custom block to do that. There's one little caveat here that we have to account for. What happens if we put 2? That doesn't really work too well, right? That's not a valid shape. So we only want it to work if the number of sides is greater than 2, right? So for that, we can extend it a little bit. Let's do edit. And what we do for this is very straightforward. We're going to do an if-else. If the number of sides is less than 2, or sorry, less than or equal to 2, so basically less than 3, we're going to say it's not a valid shape, and otherwise we're going to draw it. So for that, all we need is an if-else. So let's go ahead and bring in the if-else. And what we're going to do is we are going to check if the number of sides is, let's say, less than 3. So if the number of sides s is less than 3, it's not a valid shape. Otherwise, we'll draw the shape. And to make it clarify that it's not valid, we will say that is not a valid shape. All right? So basically, what we have is we're going to specify the number of sides. If we have less than 3 sides, it's going to say it's not a valid shape. Otherwise, it's going to draw the shape using this formula. Let's check that out. So 2 is not a valid shape. 1 is not a valid shape. 0 is not a valid shape. But 6 will happily draw the hexagon all the way to any shape that we want. All right? And with this, we actually complete the lab. This is all of the parts of the lab to get full credit. This has covered abstraction through detail hiding by providing the details only through one block and hiding all of the details inside that block, and generalization by allowing us to find something that the patterns have in common and use that logic to do something in a general sense. So we are able to just draw any general shape or draw a square of any general size. That's generalization. And with that, we covered abstraction, which I believe is one of the most useful concepts. That's the end of the lab. However, if you're interested, there's a couple bonuses we can do. We can play around with this a little more and see how we can extend this work. Okay, so from this part on, everything we're going to do here is bonus. It's not required in the lab, but it's just some other cool stuff we can do to make this custom block we just made a little more interesting or more useful. So one thing that we notice, by the way, here is no matter what we draw, our shape always has a length of 100. Now we actually resolved that issue pretty early on. So we can actually apply that same solution here to draw a block where you can also specify not just the number of sides, but the length of that side. So let's take a look at how that would work. In our custom block, this is the same one we had at the end, we're going to say make a shape with number of sides s, and we can add a little more to that. Let's call it, make sure you select title text, and side length n. So we can also specify how long the sides are. So here we're going to click on n so that we can put a little text box so that we can specify the size. And we're going to make it, instead of a title text, we're going to make it an input name. That makes it into a variable. So now we can both specify the number of sides as s, and we can also specify the length as n, right? So we're going to use n like we did in the previous example instead of 100. So instead of always being 100 steps, it's now whatever we decided goes into this text box. Now when I hit OK, what you'll see is we have this much longer block called make a shape with number of sides 3, and we can specify the length now. So let's say 100. We'll draw the same triangle. We can make as 50. It'll draw a smaller triangle. Let's draw the same 100. We can make it maybe 60. So notice that no matter what, we can always specify the length, and it will draw a bigger triangle. And we can also make this work for other shapes. So maybe for a pentagon, I'll make it a pentagon of size 60, but I can also make it size 100. Right? So here we've provided abstraction in order to hide both of these details. We hide how we do the number of sides and also how we handle the length. And we have generalization because we have a generalized approach to any number of sides and any length of sides. So this is a good way to do abstraction. Now here's a nice little trick. Maybe instead of specifying the length, you might want to always have the same sort of length. But what you might want to do is you want to always have, you want to specify the number of sides, but you want the shape to never be too big. So what do I mean by that? Let's get rid of this thing we did at the end. So let's delete some of these last parameters we added. Let's start with the original solution, which is make a shape with number of sides s. And let's say it's always 100 steps. Now the problem we run into this with our original solution is if this number if it's small, it's okay, it draws a shape. But let's put like 100 here. What you'll find is that the shape gets too big and it kind of goes off the map. In fact, the bigger this number, the bigger the shape. Notice that each shape is always bigger than the previous one, right? So if you do a little bit of clever math, you can actually make it so that the shapes are always proportional. They're always around the same size, so that you don't have this issue with these shapes that are way too big. Now again, this is bonus. You don't have to understand what we're doing here. It's just an idea of how you can apply some clever math to do some nice tricks with programming. So let's check this out. I'm going to edit this. And what I'm going to do is a little bit of clever math here. I'm going to, instead of always moving 100 steps, I am going to move 100 steps divided by the size of those steps. Now what this is going to do is it's going to make it so all the shapes are proportional. Let's try this out. If you draw a size 4 shape, so square, it's going to be pretty teeny. But if you keep drawing different shapes, you will find that they're all about the same size. Even if I do 100 sides, it's going to be about the same size as before, right? We can maybe make this a little bigger. Let's say 300 divided by a number of steps. Draw a bigger shape, but no matter what shape you draw, it's always going to be about the same size. It's going to be proportional in size. You don't have to understand why this works this way. It's just an example of how you can apply some clever math to further refine your abstractions for things like drawing shapes. And with that, we've actually covered everything for this lecture. In fact, the last 2 examples were just bonus, just extra fun stuff. But with this, you have everything you need for this lab and all future labs, because now that we know how to make custom blocks, you can really do a whole lot more stuff in Snap. All right, so have a great day. It's been a great lab, and I will see you next time.